Hello everyone, welcome to the VRC25 Masterclass on Viction. My name is Lack and I'm a Viction builder. I'll be taking you through this workshop today. I've been working at Viction for almost 3 years now and I've been in the crypto sphere for more than 6 years. My background is in robotics engineering and I specialize in product development and growth in the blockchain industry. My goal today is to break down some of the more advanced topics for you into more easily digestible content. It's vitally important for you to understand the fundamentals in order for you to be able to build products that function smoothly and are appealing to users. So today we're going to be focusing on how to make best use of the zero gas experience on Viction and using this as a developer in your products. So we have all experienced some of the difficulties in needing gas for joining a new network or trading in a new environment, interacting with the apps. So we have specifically designed the VRC25 standard to address these problems, remove the friction for users, and have an overall smoother user experience. So I'm going to be taking you through some of the theory behind this unique standard, as well as the other standards on Viction as well. There'll also be a coding demonstration as well at the end by Mr. Ching. So stay for that. So today, just to cover some of the topics we're going to be going over in this workshop. So we're going to learn about Viction and its consensus mechanism. We're going to learn about the Viction development environment, all the token standards on the network. We're also going to go an overview of what gas is on EVM chains and VRC25 and its fee customization features. We'll learn about how this interacts with the Vicin Z protocol, and we're going to learn how to deploy a VRC25 token and use all the gas sponsor functionality for it. By the end of this workshop, it's our goal to be able to have you effortlessly deploying VRC25 and building great products for onboarding the next generation of users. So Viction has made strides in becoming a pioneer in this fast-moving industry. We've built the infrastructure to seamlessly integrate an ecosystem of dApps and tradable tokens. The unique blockchain architecture allows for frictionless payments and enables a secure, decentralized store of value. Let's take a look at some of the history and the metrics that drive a lot of the performance on the network. So our journey began with an ICO on Ethereum back in March of 2018, under that time at the name of Tomo Chain. By December of the same year, 2018, we successfully migrated over to our mainnet. And since that moment, our mainnet went live. It's maintained a track record of 100% uptime. That's almost 5 years now. So last year, we underwent a phase of rebranding to signal a new direction and focus in the network. We are now known as Viction, and we're embodying the spirit of the old and the versatility of the new, with a more people-focused approach to our network. So our network boasts near zero gas fees, a 2-second block time with transactions confirmed in 4 seconds, and a capacity to process up to 2,000 transactions per second. To put some of the gas fees in perspective, sending a simple transaction from one wallet to another will cost less than 1/1000th of a cent. So the network is fully compatible with the Ethereum virtual machine, making it a great place for easy development in Solidity. From a security standpoint, we've got double validation, so masternodes share equal responsibility to run the system and keep it stable. This ensures stable block rewards between masternode owners and stakers, and this is because masternodes take turns in validating the network in a predetermined order. To ensure that this predetermined order remains secure, a second masternode is chosen at random to validate that transaction. So a total of 2 signatures is required in order to push blocks on the network. So double validation and randomization, it helps prevent forks in the network, as well as mitigating risks against fracturing communities that come from that. So these extra layers of security, they do provide extra security, but has very little compromising on network performance. At Viction, we wanted to find a way to build a scalable and secure network that was cost-effective, quick, secure, and also resistant to hard forking. We were keenly aware of a lot of the scalability problems that existed in the 2017 bull market, as well as fracturing communities caused by major hard forks of networks. So to effectively solving the blockchain trilemma required coming up with a novel consensus mechanism. Through dedicated research and development, we developed proof-of-stake voting consensus mechanism, and that was created to power the Vicin blockchain. So the proof-of-stake consensus mechanism was optimized to provide a faster, cheaper, and more secure system that upholds the principles of decentralization by also implementing a system of governance within the validator network, setting it slightly different from proof-of-stake. So the innovative system relies on a maximum of 150 masternodes running the network, and each of these masternodes are governed by users that actively stake their assets to these nodes. So in order to become a masternode candidate, validators need to deposit a minimum of 50,000 VIC tokens to the voting smart contract, and you also need to meet some minimum hardware requirements as well to run the nodes. Then these depositors are listed as masternode candidates. From there, the voting DApp allows coin holders to vote for them by sending VIC to the smart contract. The list of masternode candidates is dynamically sorted based upon the amount of voted coins for each of those candidates. The performance is tracked and it's reported back to coin holders in terms of CPU performance. You've got total numbers of signed blocks. And then at this time, coin holders can then choose to vote for which masternode that's going to try and give them better performance and better ROI on their staking there. So the way that we've kind of done this is trying to keep masternodes secure and honest, trying to keep them online as much as possible, but then also limiting the number to ensure that there is stable running of the network. So this system architecture, it allows for serious performance and scalability while ensuring a high level of decentralization is met. So Vicin is fully compatible with the Ethereum virtual machine. So the Ethereum virtual machine is a crucial component of any EVM compatible blockchain. It's a runtime environment that executes and processes smart contracts on the network. The EVM also manages the state of the blockchain and enables all smart contract functionality. Nodes on Vicin keep copies of transaction data, which the EVM processes to update the distributed ledger. So smart contracts are the self-executing contracts with the terms of the agreement written directly into the code. So the EVM, it's responsible for running these smart contracts in a decentralized and trustless manner. Smart contracts on Vicin, they're written in the programming language Solidity, which you're probably familiar with. These contracts are then compiled into bytecode, low-level language that the EVM can understand and execute. So an important part of an EVM network is gas. So gas is the unit to measure the computational work required to execute your smart contracts. So users on Vicin will need to pay for gas using the VIC token. So Vicin has developed unique token standards to help remove the friction of gas requirements for users by providing a gas-free experience with the VRC25 standard. So later in this workshop, I'm going to go over some more detail and to actually understand how these gas-free functionalities work and how they interact with the network on an infrastructure level. So Vicin, we have an open source GitHub repository that's detailing all of our token standards, contracts, all the information you need. You can use this to help you with your development process. You can also use open source libraries such as OpenZeppelin if you need as well. We've also got development tools for both mainnet and testnet. So our in-house blockchain scanner, Vicscan, is an excellent tool for testing out your smart contracts, also available on mainnet and testnet. We've got a token issuer available for deploying smart contracts without coding. But the same issuer is also crucial for using the gas-free functionalities available on Vicin. The gas-free functionalities of VRC25 are available for both mainnet and testnet. You can see the link to the faucet here as well. You can request testnet tokens for building and testing out your products. In every blockchain ecosystem, the token functions as the central element of a new type of economy. A token standard defines a set of rules that governs its issuance and use. You may be already familiar with ERC, Ethereum Request for Comments, which is the technical standard used for smart contracts on Ethereum. This terminology is the origin of VRC tokens as well. So VRC20 was the first standard on the Vicin blockchain. So VRC20 tokens, they're fungible, meaning they're interchangeable and can be divided to smaller tokens in units like VIC. So when users transact a VRC20 token, they'll need to pay the gas fees in VIC. This is the native token for Vicin. The development is pretty straightforward for using VRC20, especially if you're already familiar with using ERC20. Now, VRC25 is an extension on the VRC20 standard. It allows for full customization of transaction fees. It's got the ability to let token holders pay transaction fees using the token itself or have gas-free experience through sponsored transactions. Without having to store VIC inside their wallet, users can transfer the token or delegate it to someone. We encourage all developers to adopt the VRC25 standard when developing on Viction. We also have VRC725. So this is our Viction's non-fungible token standard, commonly known as NFTs. So non-fungible tokens, they're all distinct and special. So every one is rare with unique characteristics, its own metadata, and also special attributes as well. Non-fungible tokens cannot be exchanged on a one-to-one basis with any other token. Tokens created from this standard are unique because the token ID and the contract address pair must be unique. So there is gas-free functionality available for VRC725, but the mechanism operates a little bit differently than VRC25, and we're going to cover those topics in future workshops for you as well. In order to make best use of Viction's VRC25 token standard, we need to have an understanding of gas and its role on-chain. So gas is a unit that measures computational work required to operate and run smart contracts on the Viction blockchain. The gas mechanism, it prevents infinite loops, resource exhaustion, and malicious activities such as spamming by requiring users to cover the computational costs of their transactions. So as a developer, it's crucial to keep gas in mind when creating and deploying smart contracts. We have two elements here. We've got gas limit, so the maximum amount of gas you're willing to pay to run a transaction, and gas price as well. So the amount you're willing to pay per unit of gas as a fee to the miner. Then gas paid to complete a transaction is the gas limit multiplied by the gas price. So gas is an important part of any EVM blockchain, but it does create a few problems in a few different areas. If you've ever tried to play around on a new chain, interact with dApps, or even send funds between wallets that you own, not having some of the native token can be a really large roadblock. Without the native token, funds and NFTs can't be moved, and you can't, interacting with dApps becomes very limited. At Viction, we've developed the VRC25 token standard to specifically deal with some of these problems. VRC25, it changes the way that users need to pay for transaction fees. We're aiming for a frictionless experience for users and trying to accelerate the road to mass adoption, onboarding the next gen of users. So fungible token standards such as VRC20 and VRC25 make up the bedrock of the Viction ecosystem. VRC20 was the first token standard created on the Viction blockchain, and the native token VIC is under the VRC20 standard. So this standard provides all the same functionality as you would with an ERC20, right? Would on Ethereum. You can transfer tokens from one account to another, get the current token balance, get the total supply of the tokens available on the network, and approve whether an amount of a token from an account can be spent by a third-party account. So anytime a transaction is made with the VRC20 token, users must pay the transaction fees in VIC. Development with VRC20 is simple and effective, but lacks many of the functionality needed for onboarding the next generation of users. So VRC25 was designed to reduce the friction for users on the blockchain. We understand a lot of the pain points on onboarding new users, and we strive to make that experience smoother. So VRC25 is an upgrade of the previous standard TRC21. Right? So the power of VRC25 comes from its fee customization functions. So there are two kinds of ways that fees can be paid with VRC25. Fees can either be paid with the same token, right? Or sponsored transactions can be used for a completely gas-free experience for our users. As a builder, you get to choose the fee structure that you want to implement. For example, if I launch a VRC25 token called Bead, users can pay the transaction fees in Bead, or if I sponsor those, they'll have a completely gas-free experience. So all fees are customized through the estimate fee function. When you create your VRC25 smart contract, you need to create a new estimate fee function with your custom fee structure. Ideally, this function will return the transaction fee based on the number of tokens that the transaction maker wants to transfer. If you want to charge fees in the token, you can customize the estimate fee function to return the fee based on the value in tokens that you pass into this function. If you want your users to have a gas-free experience, you need to pass 0 into this function when calling your estimate fee. After deploying your smart contract on mainnet or testnet, you need to register your token to the Vicin Z protocol to make full use of all the gas-sponsored transactions. Note that the transaction fees on the back end still will be paid in Vic, and this is handled by the VRC25 issuer contract. And we'll soon dive into how this fee customization works on the infrastructure level. So we see VRC25 as paving the way for the road to mass adoption, removing roadblocks for new users that want to enter the ecosystem. As a builder, there's many ways you can utilize these functions, especially in the realm of DeFi, social, and also gaming, which is a really big one as well. Let's take a look into how the VRC25 standard works and what's involved on the infrastructure level to actually make this happen. The foundation behind VRC25 standard is the Vicin Z protocol. The Vicin Z protocol was designed to simplify and improve the user experience for token transactions by eliminating the need to hold native tokens when paying for transactions. So Vicin Z is integrated and operates within different layers of the Vicin stack. So the Vicin issuer smart contract is a crucial part of the functionality of VRC25. Token issuers register VRC25 to the Vic issuer smart contract, and this acknowledges to the masternode network that the issued token will be following this protocol, the Vicin Z protocol. So the Vicin Z core protocol is integrated into the consensus layer of Vicin. If a VRC25 token is registered to the Vic issuer contract, Vicin Z enforces all transactions to the VRC25 contract to follow this protocol. So this is what changes the fee structure on the infrastructure level. Vicin issuer acts as an intermediary between the token and the masternode infrastructure. So if you can see on the diagram on the right here, you can see there are two ways that the fee structures work. So the top shows you a typical VRC20 fee, right, where the sender is required to pay the gas fees to the masternode network. The second is an example of a VRC25 token. You can see the issuer contract acting as the intermediary between the masternode and the intermediary to the masternode network. So the masternode still receives their payment for the fee in Vic for processing the transaction, but this comes from the issuer contract. So you as the project creator, you need to sponsor the transactions through this issuer here. So in order to deploy a new VRC25 token, there are a few requirements for your contract and a few extra steps needed for full functionality of the contract. As we learned earlier, the Vicin Z protocol is what powers this gas sponsor functionality. You need to register your contract with the Vicin Z protocol so the consensus layer knows how to interact with your contract for the gas sponsor functionality. So to register your contract, it must meet the VRC25 requirements. You can see those full requirements in our Gitbook docs, but this includes implementing the iVRC25 interface. You need the 3 first storage slots in the contract for balances, min fee, and owner. So please do not change the order of these storage slots because the issuer needs to read these when it's actually registering your token. You also need to implement the permit extension as defined in EIP 2612. This permit acts as a fallback in the case that your token isn't registered for the gas sponsor functionality or the sponsored Vic actually runs out, so that the users can pay transaction fees normally, right, and not in the sponsored way. So once you deploy your smart contract on mainnet or testnet, the owner of the token needs to call the apply function of the VRC25 issuer contract. Okay, this contract has the same address on mainnet and testnet. So once your contract is registered with the protocol, you need to deposit a minimum of 10 VIC to the VRC25 issuer contract. This can be done through the VIC issuer website, and you can see that on the right here. You enter the contract address and the amount of VIC that you want to donate. And note for testnet, you can request tokens through our faucet. So now, when there is a transaction call to your VRC25 token, the gas fee will be paid by the issuer contract. When the VIC in the issuer is exhausted, users are going to pay their gas fees normally unless you deposit more VIC into the smart contract. Note that anyone can actually deposit VIC to that smart contract. You just need to go over to the VIC issuer website, enter the address and the amount of VIC to donate. Okay, so now we're going to move on to our live coding demonstration by Mr. Ching. In this demonstration, we're going to be going through coding an example of a VRC25 contract, deploying the VRC25 contract on the Viction testnet, registering the contract with the issuer, VRC25 issuer, requesting tokens from the faucet, depositing tokens to the issuer, and then also a demonstration of the gas-free functionality. Go ahead with the live coding.
Thank you and hello everyone. My name is Jun. I'm a blockchain developer from 98. For this live coding demonstration today, I'm going to walk you through the VRC25 token standard on Viction. It's really similar to the Ethereum ERC20 token standard. As you can see here, one of the difference is the event fee, which will emit the fee value that the from address need to transfer to the issuer address for every transaction is made. The issuer function returns the owner of this token contract, and the estimate fee function returns the fee needed to transfer an amount of token. In the simple implementation here, I have the estimate fee, which will take 10% as the transfer amount as a fee for the issuer. And I'm gonna deploy this VRC25 token on the Vision testnet. And then after the transaction is set, okay, the contract has been created here. And we're gonna need the constructor argument for verification. Here we will verify the token contract we have deployed. And the Solidity source code, I have prepared the flattened version of this VRC25. And now submit. And after verification, we will be able to interact with this token contract right on Vicscan. And now we're gonna try transferring some token using my account number 2 with some initial balance. Okay, transfer to a random contract. I will transfer 10 token A and see how much the transaction fee will be. Here on the Explorer, I transfer from my account number 2 to the token contract address for 10 token A. Then 1 token A will also be transferred as the transaction fee to the initial issuer, which is my account number 1. Another special gas functionality of Viction is the VRC25 issuer. This built-in VRC25 issuer contract will sponsor gas from the token issuer for everyone who interacts with the VRC25 token contract. Here, as the issuer of this token A contract, my account number 1, I will apply for the VRC25 issuer with at least 10 Viction. This 10 Viction will be used to pay for the future transaction which is interacting with the VRC25 token contract. And now I will try interacting with this TA token contract by approving the number of token. And here the fixed can show that my approved transaction is gas sponsored by the VRC25 issuer, not only approving, but other interaction with the token contract, like transferring, minting, or burning token, will also be sponsored by VRC25 issuer until we use all the 10 Vicin we deposited earlier. And that's all for the live coding demonstration today. Thank you everyone for listening.
Thank you, Mr. Ching, for showing us how to deploy and effectively use the VRC25 standard. So we now come to the end of our workshop. Just to summarize a few of the key points we've made throughout this workshop. So Viction, it uses the proof of stake voting consensus mechanism for optimal performance. We've got three main standards: VRC25, VRC20, fungible standards, and VRC725, our NFT non-fungible standard. VRC25 offers full fee customization including paying transaction fees in the same token or having a gas-free user experience through sponsored transactions. Gas on EVM networks power transactions on the blockchain. And the VRC25 standard uses the Vicin protocol, Vicin Z protocol, to sponsor gas transactions. The Vicin Z protocol is on the consensus layer on the Vicin blockchain, and a gas-free user experience can also help onboard the next generation of users. So we hope you enjoyed this technical workshop today. It's our goal to educate you on some of the fundamentals on the Vicin ecosystem so you can go out and build great products. So let's build on Vicin. Thank you.